Now you can see here, 3 rays of light I have taken, and according to the wave theory, Huygens wave theory, I have taken this one like a waveform, and I have taken one particular amplitude here, crest you can take, and particles I have checked, all are in same phase, and here higher intensity, lower, higher intensity, like that. It's a line or surface joining all the particles which are in phase is called wavefront. So this is plane wavefront, this is spreading one, right? So this is called what? Spherical wavefront. Okay. Next, let us discuss about Huygens principle. So according to Huygens principle, let us see. Okay. 2 diagrams I will take. There are 2 principles. Okay. First one, source. Light travels in these directions. One particular point will take. Wave I am not showing. Assume it is there. Okay. Like this. Fine. So right now, Huygens principle, source illuminates, sends out light in waveform. I have just shown the array diagram, okay, because we know it's a wave, okay, according to Huygens principle. So one particular wavefront I have taken, of course it is a spherical wavefront. Okay. Now, this wavefront, leave it. If I take one more higher intensity position, and there also if I take the wavefront means, okay, I will take this one as A, this one as B. I will just draw a tangent, okay, to this. I will just make a circle. Hope now it is visible for you clearly. What is this circle? I just make a dotted circle was there. Complete circle I have done. Now, one more tangent I will draw, okay, to the circles. I will take this one as A dash, B dash. I think now it is clearly visible for you, the diagram what I have drawn there. Okay. So now, when he started explaining regarding his Huygens principle, okay. So source emitting wave, light wave. Wavefront is there. One wavefront I have shown you here at exactly the circle midpoint I have taken it, okay, like this, A, B. So it's a wavefront. That means it gives the relation. That means when the particles all are in same phase. Here phase I have taken as higher amplitude I have taken. Yes. The tangent drawn to the wavefront. Which wavefront here? It is the first wavefront I have taken. Correct. So it is called primary wavefront. So what is that? AB is the primary wavefront. That means first wavefront after the source I have taken. What is A dash, B dash? That means it's just a tangent drawn. Okay. So A, B, that wavefront is there, right? Next, after that, when you go for one more wavefront, again, 3 circles we can draw. See, this is called one more wavefront. That means, which one is first one? This one. So this is primary wavefront. This one is secondary wavefront. Secondary wavefront, primary wavefront. The tangent drawn to the primary wavefront behaves as source for secondary wavelength. Correct? Though source was single, when you go for secondary wavefront and look back, this primary wavefront behaves as what? Like source for secondary wavefront. So for this one, this is the source. This one, this looks like source. So that is what it is explained here. A dash B dash means it's a tangent which is drawn to the primary wavefront, which behaves as what? Source for the secondary wavefront. That means when secondary wavefront is drawn, this edge of this primary wavefront looks like what? Okay, it looks like what? Similar like a bulb. Correct? It's not visible for us, but it behaves like that. He has explained in Huygens principle, where light travels in hypothetical medium, and that is actually the medium is actually the ether medium. All those were the explanation done by Huygens principle. So I go for the principles here. I already explained you. So first principle. So you can see the diagram there. So according to the first principle, the explanation was what? Yes, each point on the primary wavefront acts as source of secondary wavefront. Correct? So this is actually the primary wavefront. Here also I have shown in plane as well as spherical. This each point will behave as what? Source for secondary wavefront. Okay? Similarly, the tangent drawn to the primary wavefront behaves as what? The initial startup for which one? For the secondary wavefront. So, second point says the surface joining the secondary wave tangentially, okay, in the forward direction at any instant gives the new wavefront. At that instant it is been explained. So, secondary wavefront means A dash, B dash here. So, what is the explanation regarding that is the surface joining these secondary wavefronts. That means, for example, right now already one primary wavefront I have shown you. Here secondary I have shown you. The surface joining is there, right, between them. Okay. Here I have shown you the tangent drawn. Here one more wavefront I didn't draw here. So, a tangent is drawn here, correct? So, that tangent, okay, which is drawn A dash, B dash, okay, in the forward direction it is because it is spreading outward, correct? So, tangentially it is in forward direction. At any instant it gives what? A new wavefront, correct? So, imagine it is at one particular time. Next instant what happens? Here one more wavefront will be there, correct? At any instant it gives what? One more, a new wavefront. When you draw tangent here, next at any instant one more tangent will be there. So, that is actually the second point of principle. First point, the primary wave, each point on the primary wavefront behaves as source of secondary wavefront. That means primary wavefront looks like what? Individual small sources. Second one, the tangent drawn or the surface in which the tangent is drawn, okay, in which the secondary wavefronts we are going to discuss, they actually behave as what? A new source of wavefronts. So, after this again one more wavefront will be there. After this one more wavefront. After this one more wavefront. So, wherever you draw a tangent, soon after the tangent what comes next is a new wavefront comes there. That means, if you draw a tangent in a forward direction at any instant gives a new wavefront. That is about the second point. Drawing any tangent at any point. Here I have drawn just like this tangent in forward direction gives a new wavefront. That is about the second principle. In different books, in different way they will explain. Suppose it is getting complicated means just remember these simple points. Each point on primary wavefront acts as a source for secondary wavefront. Tangent drawn to the surface, okay, at any point, tangent drawn, okay, they behave as what? Source of new wavefront. That is what the principles regarding Huygens principle. Okay. Yes. So, types of wavefronts also you know. There are three types. One is which one? Spherical wavefront. Example for spherical wavefront, a bulb which is kept in finite distance. So, remember light received from a source, a single source, and in finite distance means type of wavefront is spherical wavefront. Light received from a source from infinite distance. What happens from infinite distance? Yes, spreading only from infinite. But while coming towards you slowly, what happens? The spreading almost, okay, from star the light will be just like what? They appear to be like a parallel rays or parallel wave. That is why it is being treated as a plane wave. So remember, light wave received from finite source, type of wavefront is spherical. Light received from infinite source, type of wavefront is, yes, plane wavefront. And light received from linear shaped source, for example tube light, discharge tube, something like that, it is actually the cylindrical wavefront. Okay. Yes. So that is about the Huygens principle. Two principles I have explained. So note down that. Okay. Yes. So let us move on to the next derivation. Important 3 marks. Derive Snell's law. Okay, Snell's law you know, right? Sin A by sin R equal to N2 by N1. Snell's law using Huygens principle. So this is the 3 mark important question from this chapter. Okay. So let us draw the ray diagram. Okay. So students, now what we are going to do is, we are going to derive the derivation, that is derive Snell's law by using Huygens principle. So it is for 3 marks. Ray diagrams you can see here, I will explain. Okay, have a look here. So pay attention. So right now, it almost looks like a ray diagrams of ray optics, but here concept is, you can see here, I will just make it more, okay, visible for you. You can see here, this blue line I have just marked is nothing but wavefront. Okay, that means 2 parallel rays of lights are coming and what? Incident on what? Medium 1. This is medium 1, this is medium 2. X, Y is a separation of medium. Okay, so parallel ray of light comes and strikes the surface. Which one is traveling more here? This particular ray has to travel more. When it reaches the surface, it's already got reached and it already went refraction. See, angle of incidence, angle of refraction, small r it is, and here at one particular point B, I have taken a perpendicular, and this is the extra distance which is traveled by ray, okay, the second ray, and with what distance it is going to travel? V1 into T I have written. Why V1 into T I have written is, you know that, right? In the basics concept of motion in a straight line, we know that velocity equal to, or speed is equal to distance divided by time. Correct? Similarly, distance equal to what? Velocity into time, or speed into time. So same thing. The distance, extra distance which is travelled is written in terms of product of speed as well as time. Here also. So let us come for the explanation part now. So a plane wavefront. Plane wavefront means what? A straight lines, correct? Rays. It looks like what? Straight, like this. So this is a plane wavefront. See, this is the line. This is the line. Okay. So BA is the plane wavefront. BA is the plane wavefront, and here I will take the name C. CD I have taken. So this is the wavefront, plane wavefront after refraction. So now initially how to explain? Consider 2 mediums, 1 medium 2 separated by xy. Let a plane wavefront incident on what? On the mediums, or the interface of the medium, and incident with the angle I, both side angle I, gets refracted R, same angle, and then what you are supposed to do? Draw a perpendicular from the second ray to the first one, so that it makes a right angle triangle here. Which angle? Right angle triangle here. A, B, C, you can take like that. Okay. So you can say triangle ABC, it looks like right angle triangle. Next you can take what? By keeping this perpendicular, that means from this you have to draw a perpendicular to which one? To the line. So angle should be 90 degree from refracted light. So you have to draw, and for that you have to take it as an arc. That means you have to just make a tangent here. For which one? For the arc. Okay. Or you can take the arc, I think it's visible for you. So you can make the arc come like this. Okay. Fine. So draw a arc for a distance of V2 into T, and draw a line from C as a tangent. Okay. So we don't know the length. So that is why what you do, remember this, here 90 degree from refracted, no? So from there I have to draw like this. So the point where it exactly meets, no? There we have to show the arc. But in experiment, what Huygens has explained, first they will draw the arc, then they will do the this one. What is that? Tangent. That becomes exactly 90 degree like this. So whatsoever. So initial adjustment of the diagram is like this. So whatever angle of refraction is there, here also angle of refraction is one and the same. So whatever angle of incidence is here, here also same angle. Okay. So now let us do one by one. Let us see. So considering thing and all, hope you understood. So right now, just by looking at the diagram, what we can say here, from triangle ABC, sin I or sine of angle of incidence is equal to, what is that? BC divided by AC. Correct? BC divided by AC. Hypotenuse, opposite side. Right angle triangle, opposite side, ascending side, hypotenuse, like that. Next, from triangle ACD, sin R is equal to, from the diagram, this is AD. AD divided by AC. Question 2. Have a careful look for the geometrical shape. So like this I have written now. So now what I do is, equation 1, equation 2 is there. So I'll just equate these two. Okay. Equation 1 divided by equation 2. What you're gonna get is sin I by sin R is equal to BC divided by AD. You get equation 3. So what is BC here? BC means V1 into T. AD means what? V2 into T. Correct? So sin I by sin R equal to V1T divided by V2T. So it is V1 by V2. That is what we get. So V1 by V2 we get to know. So you might be remembering this, correct? So the relation already in ray optics you have discussed. So refractive index means it is also, what is that? It is the ratio of speed of light in both the mediums, correct? So now what we do is, we'll go for the relation between absolute refractive index. What is that? N1 is equal to C by V1, correct? Similarly, absolute refractive index of second one is C by V2. That means individually if you take the mediums means, okay, its absolute refractive index N1 is what? Speed of light in that. Next V1, correct? This is comma, okay? This is V1. Yeah. Next, absolute refractive index of second one. What is that? N2 equal to C by V2. So now what I do, I'll just go for ratio of that. So ratio of that, if you take, it's same as that of what? So this is N2 by N1 equal to V1 by V2 you will get. Am I right? Write neatly. So by looking at this equation number 4 we take. So what you have to do after writing this? Absolute refractive index is given by N1 equal to C by V1, N2 by equal to C by V2. See, just ray optics concept I am writing here, nothing else, okay? So I am just taking that this side. So V1 by V2 means we know what is that? N2 by N1, correct? So N2 by N1 ratio, correct. So now what I do, I will write that as it is here. So this is sin I by sin R equal to N2 by N1, also equal to N1 sin I equal to N2 sin R. See, we have finally proved. What we have proved? Snell's law, by using which one? Huygens principle. So for refraction, reflection, everything it holds good. But later on what happens? Slowly the electromagnetic theory comes slowly. So what happens? Huygens principle has got some demerits. That is why it is being just neglected. But we are studying that in wave optics. But slowly, when you go for next chapter, dual nature of radiation and matter, where we study about the wave nature. Apart from that, electromagnetic theory and all, we are going to study. Okay. So explain once again. Parallel ray of light comes and strikes one of the interface as it is plane wavefront. BA is a plane wavefront. After refraction, it is the plane wavefront. Okay, wavefront. And as the geometrical shapes looks here, so this is angle of incidence. This is also angle of incidence. Angle of refraction angle here it becomes one and the same as there is a 90 degree and there is an arc which is drawn. And this is actually distance traveled by light after refraction. First ray, second ray, this one. Okay, that means before refracting, this is the angle. So two right angle triangles are there. By using the trigonometric functions I have taken here, by evaluating that it is same as that of our Snell's law. So easily you can arrive at this relation. So diagram, I think it is visible for you. Okay. So hope this derivation will be easy for you. Very small 3-mark derivation it is. Okay. Yes. So that is all about today's topic, that is introduction to the wave optics. Apart from that, different types of wavefronts, how they are generated, for finite distance, infinite distance, what are the concepts we have to learn regarding the wavefronts. I think you understood that and it's clear for you. And regarding principle of Huygens principle also we discussed and I have listed out. While I just explain that, those points you take down, so that is nothing but the principles. And then 3-mark important derivations we have done here, and it is actually derive the Snell's law by using Huygens principle. Diagram very simple, and just use the trigonometric functions. By taking the ratios, this will be the final answer. Okay. Yes. So fine then. Hope it is very clear for you, and thank you.